Hey Internet, welcome to Thermodynamics tutorial. This is a made-up question not found in your textbooks. Once again, we're trying to find the frictional power to overcome in the pipes. This is a similar question to the previous one. So, in this case, they make it a lake and a pool. So from point A to point B, we are still siphoning water from the lake and to another destination. They changed the height to 81 feet. The efficiency of the pump is 81%. The power input is 21 horsepower. The volume flow rate is 1.6 cubic feet per second. Okay. So as you can see, this is an imperial or US customary or English unit question. Step 2, list all the given variables and find the unknown. So we're trying to find the frictional power. They give us the power of the pump, the height, the volume flow rate, and the efficiency of the pump. So 21 horsepower, 81 feet, 1.6 feet cubed per second, and 81% respectively for the units. Step 3, find the frictional power formula. So it is the useful power of the pump minus the mechanical power. So both are missing, so we're going to use the mechanical power first, or find the mechanical power formula, because that one's given and it's easier. So it's just density multiplied by volume flow rate multiplied by gravity multiplied by the elevation, Z, or you can call it height. So Z and H are interchangeable. Okay, they do have meanings depending on the question, but in this case they're the same. Alright, so we're just going to plug and play. So this 62.4 pound mass per foot cubed, this is the density of fresh water from the lake. And then gravity is 32.2 feet per second squared. The rest are given. Make sure you've got your conversion factors to get it to horsepower. So your mechanical power is 14.7037 horsepower. Step 6, find the useful power formula. So it is the efficiency multiplied by the power of the pump. So I'm just going to use the symbol that some have shortened useful to just U, but I just put it in full so students don't get confused. Step 7, find the useful power of the pump. So 81% multiplied by 21 horsepower, you get 17.01 horsepower. Step 8, we can now backtrack and find the frictional power. So mechanical is in step 5, as seen here, and we just worked out the useful power of the pump, step 7. So 17.01 minus 14.7037 horsepower, you get 2.3063 horsepower of frictional power. So in this fine print, it just tells you that you need that additional 2.3063 horsepower to overcome the friction in the pipes. So we can zoom in on that note if we really want to. As you can see, that's just what it says. Okay, disclaimers. The method is correct. However, I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answer. Now before we leave, I highly encourage you to save this video onto your PC just in case this video or channel gets taken down. While I follow all copyright laws, sometimes things just happen. You can do this by clicking on the icon in your taskbar for snipping tool. If you're on a Mac, use the Mac equivalent of snipping tool. If it's not in your taskbar, go to your Windows search, type in snipping tool, open up the program, click on video option, click on new, left click and drag the rectangle to cover the YouTube screen. This is just an example. Hit the start button in snipping tool, wait for the countdown, hit the replay button on YouTube, let the video finish, hit the red square in snipping tool to stop recording, and then save your video. Thanks for watching. Hope you had a great day. Be sure to like and subscribe, share with your friends, because this is a made up question, so they probably won't be able to find it. If you got questions, comments, or if you find a mistaken video, leave it in the comment section. I'll get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.